So when we long divide, all right, what we do is we take our 12, okay, we put it in front of this like little, I don't know, like this box symbol here. I don't even know what you would call this thing, but it's there it is. Okay, we're going to put the number that we are dividing inside of that little box. Okay. All right. This is called the divisor, the thing that we are dividing by. This is the dividend, the thing that is being divided. And then our answer up here is the quotient, right? We'll get to that here. So, the way this kind of works, all right, is you look at your number right here, 12. Okay? And you ask yourself, how many times does 12 go into, and then you start with just the lead coefficient there, the number, 2. So, how many times does 12 go into 2? 0 times evenly, right? Like you can't divide 2 by 12 evenly, right? Like 12 does not go into 2 at all. You can't do it, right? But so since there's nothing there, you can put a 0 if you want to, or sometimes people put like a little X there or something like that, or you just like leave it blank. That's fine too. So it didn't work, right? So then we'll add on the 7, and so now we are not considering this to be 2 and 7. We're considering this to be 27. And so think about 27. How many 12s? Okay, can we take out of 27? And the answer is 2, right? Okay, because 2 12s is 24, and so we can take 24 out of 27, no problem. So we'll pick a 2, and we're going to put the 2 right above the 7 here, like so. Okay. All right. And since we're going to take out those 2 12s, it'll be 2 times 12, right? 24. And we're going to subtract. Okay, so what we're doing here is kind of like a repeated subtraction, right? Multiplication, when you first learned multiplication, you might not remember this, right? It was like elementary school so long ago, but one way to think about multiplication is it is repeated addition, right? You keep adding the same number over and over again, right? 3 plus 3 plus 3, or plus 3, so that's 3 4 times. In other words, 4 times 3, that's where that word times comes from, because it's, literally 3 4 times, or 4 3 times, kind of thing. That's where you get the word times from multiplication. Okay. Here, division is repeated subtraction. Okay, the opposite of multiplication. So 2 times 12, like I said, 24. We're going to subtract these things. So when I subtract here, what's left? 3. Okay. Can 12 go into 3? No, right? So we have to bring down then this 7. And now we can ask ourselves the question again. Can 12 go into 37? Yes. How many 12s? 3 of them, right? Because that would make us 36. So 3. 3 times 12 is 36. And we subtract. Okay? That 1, right? There's no more numbers over here for us to work with in some sense. Well, I'll talk. There is, but anyway, I'll stop right there. There's no more numbers for us to bring down, right? And so this 1 is known as the remainder. Okay? We cannot bring down any more numbers. So you have 2 options at this point. Option 1, we can take that remainder, and that remains, right? It remains to be divided by 12. Like this is what's left over that still has not been divided by 12. The rest of this has been except for this 1. So you could say, okay, the answer here is 23 and 1/12. Okay? That's one way to write the answer there. The remainder is 1. So there's a 12th still that has to be, the 1 has to still be divided by 12. And that's our answer, 23 and 1/12. Okay? Alternatively, if you want to figure out what the decimal would be, you put a decimal point here. You would add a 0, because 277.0 is the same thing still as 277, right? I'm not changing the number here, I'm just adding a 0 on. You drop the 0 down, and then continue on as you normally would. But of course, in this case, if I drop the 0 down, I would then need to put another 0 because 12 can't go into 10. So I put another 0 in 100. And then you'd ask yourself, okay, and also you start a decimal point here. Sorry, there too as well. And you ask yourself, okay, how many 12s go into 100? And so what it would be 8 of them, I think. Because that gives you the 96. And so you put like an 8 up here, and then you continue on. Okay. Or it would be a 0. 0, and then an 8 like that. Because you had 0 12s to go into the 10, and then you put the 8 like that. And you go from there. Okay? That's long division. All right? Questions on any of that? Okay, it does make sense, yeah.
Mine was a little bit different the way I was taught.
Okay.
Mine was where you just like subtract like 12, and then if it subtracts, then you do one tally, and you go all the way up to 23.
Yeah.
That's really terrible right now.
Yeah. Yes, that's another way to do it. Your choice. Okay. Yep, you can leave it as 23 and 1/12 if you want to. In fact, that's what we will be doing with our. Yeah.
Like I was just like I was taught to like keep going until you like kind of zero.
Okay, or until you like repeat.
Yeah.
Until you finally repeat. Yeah, you can do that. That's fine. But also the remainder becomes the fraction, 1/12. So that works too because it still has yet to be divided by 12. All right, so let me have you guys try one. Okay, so let's have you try. I don't know. 312 divided by 9. Okay, I'll leave that one up there. You guys go ahead and give it a try. I'm showing you the harder division first, long division, and then I'll show you a shorter way later. But you will need to know both. Okay, again, there is not going to be one method that works in all situations. Well, long division will work in all situations, but I'm going to guess you'll want to avoid it if possible. Okay, so I'm going to go do it real quick here too because I haven't done this one yet. Yeah, go ahead. It would be, so the remainder is 6, still divided by 9. 6 divided by 9 would not simplify into 1.
Yes.
So close. The remainder here is 6. So what would be 1 over 9? There was 1 over 12 here because the remainder is 1. So 1 over 12. Here you have 6 over 9. So that's
Wait, Professor,
yes.
would you simplify the fraction?
I get it. Right. It's fraction.
I was it was out.
Or just get a bigger pot.
I'll do it. I'll do it. His hair is not able to top.
Okay, that's going to be your
Oh, I get like a pocket right here in the third. I mean, or the
okay.
pocket extension. No, right here.
So it'll be 34 and 2/3 now. All right, we're looking pretty good. Feeling pretty confident. Yeah. So, like in a situation like this, okay, we know that from our answer here that 6 over 9, 6 ninths simplifies to 2/3, which we know, or you might know, and hopefully you will come to know, that 2/3 is always going to get that decimal of the 0.6 repeating, right? And you can see it happen here in the algorithm, right? If you if you put 0 here, like you add a 0 and a decimal point here, drop that 0 down, we'll end with 60, right? 9 goes into 60 how many times? 6, right? So if I put a 0.6 there, 6 times 9 is 54. 60 minus 54 gives me another 6. Okay, add in a 0. Drop the 0 down. It's 60. Put in a 6. 6 times 9 is 54. Okay, 6, put another 0, drop it down, 60. And you see it's going to continue on, right? We're going to repeat that algorithm over and over and over and over and over again. So that's where that repeating decimal of the 6 comes from, okay? Because we keep ending with the same, process over and over here, okay? Over and over. So that's kind of the idea there. Questions on any of that then? We're good? Okay. And again, if you chose to make that 6/9 for the fraction, that's okay, but you could simplify it to 2/3, right? And then, of course, make it with decimal there or whatever. All right. But, of course, that's not what we're here to learn today. We are here to do division with polynomials, right? So here we go. So I want to start with a little bit of an easier one. Boop, 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 boop. Let me pick an easier one. That way I'm not going to scare everyone. Not a big fan of any of these. Okay, here we go. Okay. Okay, so let's not freak out just yet. All right, let's go back to what we know, right? Something divided by something, okay? So the dividend, that's the thing in front, right? This thing, it goes inside of our little box. And yes, we're going to use that exact same box. Or not even a box, really. I don't even know what you want to call it. Half box. Okay, just like that. And the divisor, x plus 1, will go out front. Bless you. Just like that. Okay. Quick note here, okay? Standard form is crucial here. Okay, so make sure your polynomials are in standard form. Okay, the polys must be in standard form. And this is important too, and we'll see a problem like that in just a second. And, okay, use 0 for missing terms. Okay, I am not missing any terms here, right? It goes from x to the 4th to x cubed to x squared to x and then to my number. Okay, but like if I miss an x squared term, if this polynomial didn't have an x squared term, I would need to put it like a plus 0x squared in there, and I'll show you what I mean by that. Okay, but you do need to put it's called a placeholder, right? You need that for the algorithm to work. If you don't put a placeholder in, the algorithm will get messed up. Same thing is true right here. If your divisor was missing a term, okay, you want to put a 0 in for the placeholder because otherwise it will mess up the algorithm. Okay? Mess up our program. All right. So far, so good? Yes. Yes? All right. So that's our setup, right? This can be tricky for students too, just getting it set up correctly, okay? Now, the next thing we're going to do is what we just did before, right? We're going to take a look at this x here, all right? That's what we're going to use to help guide us. Not the plus 1, that's part of it, but really we need just this lead term here, okay? And we're going to then compare it to this lead term, all right? And I want to know, what do I need to multiply this x with to get this x to the 4th to go away, right, to cancel out. So what times x will give us that x to the 4th there? X to the 3rd, right? So yep, x to the 3rd. Okay? So when I take that x to the 3rd, I'm now going to multiply to the divisor, just like we did here. When I picked that 3, it was 3 times 9, we got the 27, right? Here we're going to do x cubed times x and x cubed times 1, right? So this becomes x to the 4th, and then x cubed times 1 gives us what? X cubed, right? So plus x cubed there. Okay. When we wrote that thing out, What do we do with this quantity now? We're supposed to subtract it, right? That's what the next thing is. So subtract the quantity. So in other words, parentheses around that mess. Okay, parentheses around it. Okay? I would encourage you, because we're like, subtracting an entire polynomial here, I always like to change this to add the opposite. And I know that adds like one more step into an already like tedious, thing, but it just helps because I find students making errors when they don't do this. And I guess they still make errors when they do, but anyway. Your lead term here will always cancel out if you chose correctly, right? We chose this x to the third so that these x to the fourths would cancel. And then we'll combine this. We have a -4 and a -1, so that makes -5 x to the third. Right? Okay. So there's my next kind of goal, right? I want to eliminate. However, I have 2 terms in my divisor, but what I have right here is only 1 term. What do I need to do to make it 2 terms? Well, what we do over here, right? When I had just a 6, or let's see here, when I had the 4, right, I brought down this 2. We're going to bring down this term as well. So we'll do minus the 6x squared there, like so. And now we repeat the process. So what times x will give us a -5x to the third? So what times x will give us -5x to the third? So let's talk about our numbers. What times 1 gives us -5? -5. And what times x will give us x to the third? X squared. So we need a -5x squared. Okay, and I think some of you guys were saying that too. It just wasn't loud enough for me to acknowledge because I didn't want you to, whatever. I heard somebody saying some of that stuff. Okay, just now we're going to multiply, right? -5x squared times x, -5x to the third. -5x squared times 1, -5x squared. Okay, and again, subtract the quantity. We will always be subtracting in our division here. Okay, that's why we want it to match up. So when we subtract, it'll cancel. Okay. Again, change it to add the opposites. Okay. What happens to our 5s? Or x cubes, they cancel, right? And we have -6 plus 5, which is -1x squared. And then bring down the 4x. Okay. All right, let's keep going, right? What times x will give us a -1x squared? So -1x, right? -1x times a positive x will give us -1x squared. -1x times positive 1, -1x. And again, subtract the quantity, which again, add the opposites. And so those cancel as they always should. 5x, bring down the plus 5. Okay, the organization of this is important too. That's why it's important to line things up here. Okay, line up your terms and stuff like that so you can kind of have it nice and organized. It helps to do the work correctly. Whew, almost done. What times x gives us 5x? 5, right? So plus 5. 5 times x is 5x. 5 times 1 is 5. Subtract the quantity, and oh my gosh, they're exactly the same. So what's our leftover here? What's our remainder? 0. The remainder of 0 tells us that this x plus 1 is a factor of this polynomial, right? X plus 1 evenly divides this polynomial. There's no remainder, so that means this x plus 1 is a factor. All right? So this is another tool that we have to help us factor this polynomial, right? If you guys looked at this right now, would GCF work for this?
No.
Would factor by grouping work for this?
Probably not.
Well, there's 5 terms. Remember, for factor by grouping, we need what kind of terms? We need an even number of terms, an odd number here. So that wouldn't really help us in this case either. So all of our methods kind of don't work. Yet, if we can figure out, what to divide by, then we can see that, oh, in this case, right, we get a remainder of 0. So this allowed us to factor. And now we have this left over right here. There's our quotient. And we can maybe try and factor this using, ooh, this one still factors, doesn't it? What can we now use to factor this? What's that? Grouping. Yeah, let's watch. So group the first two, group the second two. From that first group, we can take out an x squared and then leave an x minus 5. From the second group, we can take out a minus 1 and have an x minus 5. And I can take out the x minus 5. I'm left with x squared minus 1, but wait, there's more. What can we still factor here? What can we still factor? The x squared minus 1. It's a difference of squares. Okay. So in other words, this polynomial right here is equal to x plus 1, the original thing that we factored out, times x minus 5 times x minus 1 times another x plus 1 there. Okay, and that there it is, fully factored. Okay. So we took something that we could not factor before. Right? We could not factor this polynomial here. We were given one of the factors. Using long division, we could divide it out, okay, and we have this result of the x cubed minus 5x squared minus 1x plus 5. Okay? That we could try factor by grouping, and it worked. And then we had a difference of squares we could further factor, and so we can actually fully factor this this polynomial here using all those little factors that we found. So yeah.
Like the final answer, are you supposed to because there's 2 x plus 1s, you're supposed to put x plus 1 squared?
You can. I'm okay with leaving it either way. I really think it's kind of like, yeah, I'm okay with either way. I think it's fine. But it's good that you recognize, yes, that you have 2 of the same factor. A double root, that'll be important for later too. Okay? Questions on any of this? Any other questions on this? Okay. So there's actually a shortcut for doing this kind of problem here. I'll show that to you in a little bit, but I want to show you one more long division problem here, and then I'll have you guys try one on your own. Okay, because long division is the harder one, so that's why we're focusing most of our attention on the long division one. Okay. So I'm going to go to a long division problem now that requires long division. The one I just showed you does not require long division. Okay, but I need to show it to you because, well, that's the harder of them, and there are situations where you will have to use that long division. Okay. Do one more here. Just show you an example of again, this is important here. Let me show you. I threw in two differences, right? So let's see here. So what's the major difference here from our last problem? So go ahead, Claire.
There are 3 terms.
Yeah, 3 terms were divided by. It's a trinomial, exactly right. Okay, that's a major difference. The good news is the general idea is still the same. Okay, there's also something here that's kind of hidden. All right, remember that when I asked you guys to set this up, the polynomials must be in standard form. Are both of our polynomials in standard form? Yes. What's that? Yes, Jonathan, exactly right. We are missing a term. What term is missing? The x squared term, okay? Please be careful, right? Because this looks very innocuous, very innocent, right? It's just like, oh, yeah, no problem. Put this in the box thing, put that thing outside the box thing, and do the work. You are missing an x squared term here, and that is crucial. All right, we must put a placeholder in when we set this up. So, x squared plus 2x minus 5 outside, right? And then inside 6x to the 4th plus 5x to the 3rd plus 0x squared. Okay, plus 2x plus 8. Okay. Now everything will be just like we did before. Okay, just like we did before. So no surprises after this point. Really, this is all. That's all you had to worry about. Making sure you put that placeholder. And that was really why I wanted to do this one. Okay, everything else should be the same. So again, there's 3 terms here we're dividing by, but we're only going to use our lead x squared to guide us. Okay, only the lead. And then we'll compare that to the 6x to the 4th here. So again, what are we going to multiply x squared by to get 6x to the 4th? 6x squared. You got it. Very good. Okay? 6x squared. So 6x squared times x squared, 6x to the 4th. And then you just keep distributing, right? So it'll be 6x squared times 2x. So that's going to be plus 12x to the 3rd. 6x squared times minus 5, minus 30x squared. Okay? Subtract the quantity. You can see here, guys, we're doing a lot of little mental math arithmetic calculations, right? So that's why I was trying to stress to you now that we get this mental math stuff down. Okay, we got to practice that. Okay. All right. Again, instead of subtracting, I'm going to change it to add the opposites. If you're comfortable with subtracting, positives and negatives, do it. Okay. But just because I want to show you guys what I think is the best practice, that's what I'm doing. Okay. 6x to the 4th, cancel. 5 plus negative 12, negative 7. 0 plus 30, 30. And then bring down that 2x. Okay, we need 3 terms here because what we're going to end up with is 3 terms, right? When I pick a number here, I'm multiplying each one of these 3 by, by that number that we pick. And so I need 3 terms to line up with here. All right. Do you guys want to try the rest?
Yeah.
So clear?
I have a question.
Go for it. Yeah, go ahead. Try the next.
6x squared.
Where did I get this from?
Yeah.
So remember, our goal here, Claire, right, is to eliminate in our subtraction, when I subtract here. So I know that my goal is to make a 6x to the 4th right here. So when I subtract, it'll cancel. If I have an x squared already, right, that's what I'm multiplying by. What I pick here, what goes here, I multiply with the x squared to cancel out 6x to the 4th. Do you see that?
Yeah.
So the 6, because it's going to be 6 times 1 to make a 6. And then I had an x squared, so all I need to do is multiply by an x squared to then get the x to the 4th. Do you see that?
Yeah.
And then for this next one then, Claire, right, my goal is to make a negative 7x to the 3rd. Right? So I need to have a negative 7, because negative 7 times 1 is going to be negative 7. Right? And then what do I need for x? So I need an x cubed. I already have an x squared, so what needs to go here? Just an x. And then you distribute to all 3, put them underneath, and continue on. Okay? Yep. Good questions, yeah. Numbers get a little large here, but I'll try to keep them small for you guys when there's no calculators involved, okay? Because that's a lot, maybe sometimes. Oh, 96, 116. Okay. So this one we're going to have a remainder, right?
See, I told you I knew how to do this. So I'm confused.
Are you? Yeah, what's your?
So it'd be 16x squared there. So we get rid of that. So that's 2x, 32x. Michael, question?
Yeah.
Okay, I'll be right there. Oh, sorry, 1 second. Let me just see here real quick.
No, something simple that I was missing. Just don't get
Oh, there it is. I made a mistake here with my multiplication, I think. Yes. Yes, I did. This should be minus 14 right here. Yep, that's my error right there. It should be minus 14. No. Shoot. Let me redo this. I feel like I made a mistake somewhere.
Yep, stuff somewhere. I think it's 35 is my number.
Okay. Minus 7x. So negative 7x to the third minus 14x plus 35x minus the quantity then plus the opposites there. So that cancels. 30 and 14 makes 44x squared, right? And then 2 negative 35 makes negative 33x. Okay, bring down the plus 8. And so then 44 and x squared, I need 44x. Or just 44. 44 times x squared would be 44x squared. Plus 88x. And then minus 220. Oh, that is what I ended up with. No, okay, that was wrong there. Okay. So add the opposites. Those cancel. Negative 33 and negative 88. Oh, question? Did I make an error?
35 plus 2.
Negative 35 plus 2. Yeah. It's negative 33, right?
Because if it's negative, I think you said plus.
Well, right, because it was a minus, but then I changed it to add the opposite instead. So it's plus, I mean, so I changed it to add the opposite, so it's negative 35. There. You got positive 35?
Well, I didn't. Like, where you like added the opposite,
Mhm.
I just subtracted it.
All right, let me see
I
here.
got like the opposite.
Okay, this. All right. Yeah, I think negative 33, negative 88. Yeah. So now this is okay. Negative 121x, and then 8 plus 228. This is the right remainder. Okay, right here. Negative 121x plus 228 is your remainder there. So, yeah, that is the correct remainder. Yes, Ash, question?
Wait, so when you multiply negative 7.
Yeah.
Oh, wait.
You're okay? All right. Other questions? Other questions? Dylan?
I just don't understand like where you're getting new numbers from. Like,
Up here?
Yeah.
Down here. Which ones? These up here?
Yeah. Those are there.
So each time, right? So the very first one, right? Okay, you're looking at your lead number here, your lead term, and your lead term here, and you're asking yourself, okay, or you want to eliminate the 6x to the fourth, right? When you subtract, you want these things to cancel out exactly. So in other words, I need to figure out, what do I multiply x squared by to get 6x to the fourth? That's 6x squared, right? 6 times 1 will give me a 6. X squared times x squared gives you x to the fourth. So then they'll exactly cancel. And then you distribute. 6x squared times the 2x, get the 12x to the third. 6x squared times minus 5, you get the minus 30x squared. You do your subtraction, right? Subtract the quantity. Okay, and so you're left with a negative 7x to the third right here, plus the 30x squared, then you bring down the 2x. So far, so good? Then the next step starts, do it again. Repeat now. So what times x squared gives you negative 7x to the third? So negative 7 times a 1 will give you negative 7. X times x squared gives you x to the third. And then again, you distribute to all the other two there. And you get these, subtract the quantity. And then you're left with a 44x squared minus a 33x, bring down the 8. What times x squared gives you 44x squared? So 44 times x squared, right? 44x squared. And then 44 times 2, 88. 44 times negative 5, negative 220. But then when you're subtracting, you change those to add the opposites. And then this is what you finally get for your remainder. Okay? This is our remainder, right? There's nothing left over for me to bring down. I have these three terms here. I cannot multiply x squared by something nice to get negative 121x. So this is our remainder. We are finished. What do we do then? So we say then the answer is 6x squared minus 7x plus 44. Okay? And then plus, and then we put our remainder, negative 121x plus 228 over the x squared plus 2x minus 5, like so. Okay? And that is how we would write our answer for that division problem. The stuff that did, divide out evenly, and then the remainder over what it still needs to be divided by, the x plus 2x minus 5. Question? Yes. All right. Ready for the easier one now? Well, I'm going to show you synthetic division at least because we got 10 more minutes left, so I got to make sure I get synthetic division in here too. Alrighty, so let's look at synthetic division, which is an easier way to do this, okay, but it only works in certain situations, okay? All right. I'm missing a page. There we go. All right. So synthetic division. Okay. Only works for p of x divided by x minus a. Okay? So it only works when you take a polynomial and you divide by like a binomial like this, where it's just x, lead coefficient's 1, and you subtract the number a. Okay, or add a number a, right? You just make it positive, negative, whatever. But it only works in this situation. So in other words, could we use synthetic division in our previous problem here with what we were dividing by? No, okay? So if you're going to use, if you're dividing by this like quadratic here, you have to use long division. However, if the quadratic factors, you could then use synthetic division with one of the factors and then take that answer and synthetically divide again by the other factor, and that would be equivalent to. Okay? But anyway, this is, this synthetic division only works when you're dividing x minus a like that. So let's go back to our problem that we did earlier, right? Which was this one here. Okay. Remember that? We did that one first, right, with a long division. But now I will show you a better way, a faster way. So if we're dividing by x plus 1, right, remember we're dividing by x minus a, so what would our a be here? If we have x plus 1, but we need x minus a, what would a have to be here? Negative 1, right? Because it's minus, we need to be negative 1. So when we go to set this up, okay, the a goes in here, so that's going to be negative 1. That comes straight from that right there. Then what we put over here across the top are the coefficients of our terms. Okay, so just like that. you're going to like leave a line. Okay, so leave like a line space there. Okay, leave a space for more numbers, and then put like a little long bar there, like almost like you're doing a sum or a multiplication problem or something like that. Okay. And we're going to use synthetic division here to divide this thing, to do the division. So I'll show you how it's going to work. Okay. So the first thing you do is we bring down the 1 and put that right here. Okay. So that's like the first step. Then you're going to take this number 1 here, multiply it with the negative 1. So 1 times negative 1 is negative 1, not a trick question. All right. And so then that new number goes right here. So drop the 1. 1 times negative 1 is negative 1. That new number goes right here. And hey, look, now we have 2 numbers to set up, and we're just going to add. All right, so okay, so we add. What's negative 4 plus negative 1? Negative 5. Okay, and the process repeats. Okay, so again, we started by dropping the 1. This number down here will multiply with the negative 1, which we put right here. Add these two, negative 5. Now the negative 5 will multiply with that negative 1 to make positive 5, and we're going to put that positive 5 right here. Negative 6 plus 5, negative 1, and the process repeats. Negative 1 times negative 1, 1. 4 plus 1, 5. 5 times negative 1, negative 5. 5 plus negative 5, 0. Okay? That number right there is our remainder. Since our remainder is 0, we know that our original factor divides evenly. Okay? It's also equal to P of A. Okay, by the way. So you can also use synthetic division to evaluate polynomials too, if you want to. Okay? You can use synthetic division to evaluate polynomials too. But what's this left of these numbers? What's the rest of these numbers left over mean? Well, it's the coefficients of our answer. Okay? So you lower the degree by 1. So we start with an x to the 4th. So this becomes 1x to the 3rd minus 5x squared minus 1x plus 5. And that's the answer that we got from our earlier division problem. It's basically what it's doing. Hang on a second. Dividend by. Okay, I'll squeeze in one more here. I think we should have time. I'll squeeze in one more. Okay. So how does it work, Michael? What is essentially, it is like that algorithm that we've been doing with long division, but it removes a lot of the gobbledygook. All right. But unfortunately, in removing some of the gobbledygook, it loses its general applicability because we can only divide by something in the form x minus a. All right. I'm going to put one more in here. Question?
How did you get 1x to the 3rd?
So the lead coefficient here, right? It's 1. So we start with an x to the 4th. Our answer will be 1 degree lower, x to the 3rd. So it's 1x to the 3rd minus 5x squared minus 1x plus 5. And then the remainder is 0. Okay. The last number will always be your remainder. Okay. Shall I do one more? Do we need to see another one?
Yeah.
Yes, one more. Uno más. All right, quickly here. Quickly. All right. Let's do 7x to the 3rd minus 6x plus 9 divided by x plus 5. Okay. So what is our a here? What's going to go in the box? Negative 5, right. It's the opposite of that there, so negative 5. Then we'll put on our coefficients. First number will be 7, right, because 7 is our lead coefficient. The next number should be
0.
Very good. 0. We are missing an x squared term here. So put 0 in for x squared, then your negative 6, then your 9. Okay? Leave a space, put a line, drop down the 7, and then just start your algorithm. 7 times negative 5, negative 35. 0 plus negative 35, negative 35. Negative 35 times negative 5. Oh, these numbers are going to get pretty big here. Let's see here. 175. Negative 6 plus 175, 169. 169 times negative 5, negative 845. Add those together, negative 836. So you get 7x squared minus 35x plus 169 plus a negative 836 over the x plus 5 there. Okay, just like that. Wow, perfect timing.
I thought you dropped it like the exponent when you drop by this is
That's
definitely
7x squared. It was 7x to the third, so it becomes 7x squared, and x is the highest term you start with. So you do load top by 1. That's all of that. Homework is on Schoology, okay? That number will then be whatever the next total 3 is. So you start with the highest 3, so you start with cubic, your answer will be then a square, then an x, then a number, and then the remainder, right? So you start with 3 next term. Okay? So, how do they figure out which one, synthetic or long?